Okay, so today we're going to be talking about permutations, section 11.1 of the Pre-Calculus 12 course and textbook. And if you would like to follow the notes that you've been provided, we can follow through those. Okay, so we're looking at starting with the fundamental counting principle. The fundamental counting principle is a way of determining the total number of arrangements of objects. So, for example, if you have n objects, then we can find the total number of ways of arranging them by multiplying how many options we have for each individual choice or choose. So in general, the fundamental counting principle begins with factorial notation. If you look at factorial notation, written as n with an exclamation mark, that's n factorial. N factorial means that you start off with n, whatever the n is, and then you multiply by one less every single time. So you're multiplying again by one less, multiply again by one less, all the way until you reach 1. So, for example, if you had something like 5 factorial, it means 5 times 4 times 3 times 2 times 1. That's what factorial notation is. Sometimes you use it, sometimes you don't, but in this first example, we're just going to stick to the fundamental counting principle. It's asking for the total number of arrangements of having a 5-digit student number, where first digit cannot be 0 and no repetitions are allowed. So if you look at this first digit, we're making 5 boxes to represent the spot for each digit for the 5-digit student number. The first digit can be anywhere from numbers 0 to 9. However, the restriction was no 0, so we're actually going from 1 to 9. That gives us 9 options for the first digit. The second digit does not have the 0 restriction, so you can actually have all the way from 0 to 9 digits to choose from, which is 10. However, with the no repeating, you have to subtract 1, and that's why you have your 10, but minus 1, so actually only 9 options for the second digit. You then subtract 2 and 3 and 4. Every time you use a digit, you can't use it again. So that takes us to the final number of arrangements of student numbers, 5-digit student numbers, where the first digit is not a 0. So that works out to 27,216. Here's another example. In this one, it says find the total number of ways you can arrange a list of grocery items that consists of 9 different items. In this case, we're taking all 9 of those items and arranging them. So we look at the first thing on the list, right? We have 9 possible items that we could have placed in the first part of that list, or the first line. Now we've used it, so we now only have 8 left to choose from for the next one. We've used that. Now there's only 7 left. We use that. Now there's only 6. We go until we get to the last list, or last item left to put on the list. So if you look at how that works, the fundamental counting principle would say 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. But what that actually is factorial notation. That's 9 factorial. In your calculator, you can see how to enter that into your calculator by pressing Math, left arrow, and then the option 4 for the PRB menu. And I'll just quickly bring that up to show you where that is. So we do this. You press the number that you want, which is in this case 9. We press Math, left arrow, and here's the exclamation mark, option 4. You press enter. So that's how you get 9 factorial. Okay, factorial is also useful for other things. For example, simplifying something algebraic like this. If you notice each one of these, there's a factorial in it. And the only way to simplify something like this is if you remove the factorial. So by removing the factorial, we can then simplify. You just start off with the first one, n factorial. We know the definition of factorial is start off at n and multiply by n minus 1. And you can continue that to n minus 2, n minus 3, n minus 4, etc. However, if you find that when you get to n minus 1 factorial, and there's n minus 1 factorial somewhere else that you can cancel, numerator to denominator, then you can cancel that. So then what we actually have is n minus 1 factorial over n minus 1 factorial canceling. So the only thing we're left with is the n. The next part would be the next factorial that we're going to look at, which is the n plus 2 factorial. So again, you start by expanding, starting off with n plus 2, then n plus 1, then n minus 1, n minus 2, etc. But if you see that it does actually match something on the bottom, you can cancel. So again, what are we left with? We're left with an n plus 2. So you have n and n plus 2. That makes up your answer. Simplified. No factorial notation. Okay. In section 11.1, you are also learning about permutations. So permutations are also representing the total number of arrangements of different objects. But in this case, what we're doing is we're only taking a few objects at a time. You can do these questions with fundamental counting principle, but there is a formula. So n represents the total number of objects. R represents how many you are choosing or picking out of the total number. So if I say n objects picking R objects, find the total number of arrangements, I could use this formula. This is also in your calculator. So again, it says in here, left arrow, math left arrow, and then option 2 for the NPR. Here's a good question. How many 4-letter permutations are there for the word flower? If you count up all the letters, you have 6, so n equals 6. We only want 4 though for a 4-letter permutation. So we have from n objects, picking 4, and that gives us a total of 360. So in your calculator, you can type that in as 6 P4. Okay? All right, so here's another way to use that formula for permutations. So here's the formula for permutations again. It was NPR equals n factorial over n minus r factorial. Well, n in this case is unknown, but the r equals 2. So you can see that written here. And it equals the total of 56. The only way to simplify this is, again, to get rid of the factorial. So you start by expanding the top. Okay, because the reason why the top is because it's going to get smaller and eventually match up to the n minus 2. If there was something else written in here, you may have to start on the bottom in a different simplifying type of question. So we have n minus 2 over n minus 2 cancels. That leaves us with n times n minus 1. And then it's just simple expand, bring over the 56, factor, and solve. But obviously, we can't have a negative number of objects, so we reject any negative numbers. The answer is n equals 7. Okay, so we have using permutations to find the total number of arrangements of something, using permutation formula to simplify and solve, and now you can use permutations to find the total number of arrangements of identical objects, or with identical objects. So here, you take the total number of n and divide it by each repeating object, however many times it repeats, factorial. If you look at this example of pathways from home to school, you can look at it in terms of directions. There's a total number of 5 easts and 4 souths, which makes n equal 9, the total number of directions in total, 5 easts and 4 souths. So if you look at the formula, you put your n on top, you put the repeating 5 easts, repeating 5 souths in the bottom, divide, and what that does is it eliminates all of those repeating paths. So that's where repeating objects need to be eliminated for when they repeat. Okay. And that takes us to the end of this section. So you will find in the textbook that there are some more elaborate questions with permutations having you solve for how many different arrangements there are of objects, but where there are restrictions. So just read the questions carefully and you can set them up in different cases and different ways like that. Okay, just looking in your textbook, 11.1 permutations, you can look at a few more examples in here. So again, it begins with the fundamental counting principle. Another way to represent a total number of arrangements could be a tree diagram. So tree diagram is similar to the fundamental counting principle, except it doesn't involve the multiplication of each of those objects, but rather actually showing visually the total number of arrangements of things and what the arrangement would be. So you can see in these two tree diagrams how they're drawn, with position 1 representing the first person chosen, and then position 2 representing the second, or whatever the question might be about. Okay, and here's the fundamental counting principle to show you that you can just take those total objects and multiply. All right, so we're going to permutations. Again, in your textbook's quite good for explaining at least what the factorial notation is, and then when you're only taking a certain number of objects and dividing by whichever number you're taking out. Okay, the difference anyways. Okay, so again, looking at the examples, you can see a few different ways of doing that. Now this is an interesting example. It says show that 100 factorial plus 99 factorial equals this, but that's basically just using the factorial notation and realizing what that means. So here you have 99 factorial common to both of these terms. Well, simply factoring it out gets you to your final answer. Actually, can you see that here? You're left with 100 when you factor out this 99. You're left with 1 when you factor out this 99 factorial. So 100 plus 1 equals 101. And that means multiply by 99 factorial. So again, solving here, similar to the question I showed you earlier. Okay, permutations with identical objects. Again, you're dividing by however many repeating objects you have. Here's a good one with aardvark. You can see in the question, or in the word, there are actually 8 letters, but there are 3 repeating A's and 2 repeating R's. So if you look at the actual answer, from 8 letters, 3 repeating A's and 2 repeating R's are divided, and it basically eliminates any repeating arrangements. So then you have your total 3,360. All right. Permutations with constraints. Again, reading questions carefully and making sure you understand what the question's asking will help you get through some of those questions. Cases as well, determining the different number of cases for depending on what the question is. It says for this one example, how many different 3-digit even numbers greater than 300 can you make using the digits 1, 2, 3, 4, and 5 and 6? Sorry, no digits are repeated. Oops. And so case 1, numbers that are even and start with 3 or 5. So you find the total number of ways of having that. So that was 2 times 4 times 3, because it gives you the total choices for each of those digits. You can see number of choices for first digit is 2, number of choices for the second digit is 4, and number of choices for the third digit is 3. Case 2, the numbers are even and start with a 4 or 6, and then again you multiply by whatever options you have. And the final answer is just a sum of those cases. Okay, so you can have a look at those questions as well.